What's going on, you guys? Mr. Allen here with some evaluation of trig functions using our double angle formulas. We got some interesting looking problems here. It looks like it's the formulas with degree measures in them, but they're not nice degrees, right? They're not our 30, 45, and 60 degree reference angles. We got 75 in this first one, but that certainly looks like this sine double angle formula, right? With theta here is 75 degrees. Let's backtrack this. That would be sine, okay, hold up, sine of 2 times theta, which is 75 in this case, right? Are we cool with that, right? We're taking the theta right there, plugging it in, kind of working backwards. What's 2 times 75? That's 150, isn't it? So sine of 150. Oh, my goodness. Isn't 150 a lovely angle for trigonometry? Yes, it's a 30-degree reference. So if you're a triangle person like I am, okay, you can always draw it up here. You can do it in your head. I'll draw it for these purposes. 30-degree reference, that's going to be a 1 here, a root 3 here. It's going to be negative, and a 2 right here. What is sine of 150? It's 1 over 2, 1/2. And you might just recognize that, remember that. You know, just they're pretty common things. But just in case you needed the triangle, I drew it for you, okay? Cool. There we go. So we're working like backwards on these things. We're like putting them back into their original form, okay? Let's see if we can do that on this next one over here. We got cosine squared of 15 degrees minus sine squared of 15 degrees. Now that certainly looks like cosine of the double angle, right? Cosine of 2 thetas. So theta, in this case, is 15. I could write that as cosine of 2 times 15, right? Which equals cosine of 30 degrees. Well, what is cosine of 30 degrees? Well, that would be, if you're a triangle person, my adjacent over my hypotenuse, root 3 over 2. If you're a unit circle person, you know, you're good to go, right? Root 3 over 2. Beautiful, fantastic. I love it. Again, I'm a triangle guy, but, you know, I don't hate on the unit circle too much. I hate on it a little bit, but it works out well, okay? But I remember triangles because I've taught geometry for many, many years, and I just remember them, okay? So, to each their own, though, you know? Next one here. We have 2 tangent 22.5 degrees, then 1 minus tangent squared of 22.5 degrees. So we're dealing with our double angle formula there for tangent. So theta, in this case, is 22.5. Let's backtrack it. This will be tangent of 2 times 22.5. So I've got, that's 45, right? Ooh, that's a nice one. So tangent of 45 degrees. Now here's where I really like the special right triangles, because tangent opposite over adjacent, that's 1 over 1. We're just talking about 1 right here. If you're using the unit circle, you're doing sine divided by cosine. You got fractions and fractions multiplied by the reciprocal, right? So I like the triangles here, but again, up to you, man. Up to you. I'm not trying to sway you any one way, or maybe I am. I don't know. All right, last one here. Oh my goodness, I don't see this one anywhere. Check this out. Ready? If I took my cosine double angle formula, okay, so cosine of 2 theta equals cosine squared theta minus sine squared theta. And if I were to replace sine squared theta using a Pythagorean identity, right, it would be 1 minus. So cosine squared theta minus, and then 1 minus cosine squared theta. Because I know I've cosine squared theta plus sine squared theta equals 1, right? So if I subtract cosine over, I'd get 1 minus cosine squared is equal to sine squared. So I can substitute that in and rewrite. Let's see what we got here. That negative is going to distribute. So we get cosine squared theta minus 1 plus cosine squared theta. So I got 1 cosine squared theta plus 1 cosine squared theta. That is 2 cosine squared theta minus 1. And oh my goodness, it's exactly what we have there, right? It's the cosine double angle formula, just a different form of it. And that's something that you can do if you want to use this on other types of problems. Like you're like, I don't see what's fitting here, and you don't remember all of your versions of that cosine double angle formula. You can derive it yourself, essentially, on the fly, because that's pretty dope. All right, so let's, now we're going to go back to cosine of 2 theta. So that's going to be cosine of 2 times 112.5, which is cosine of 225. Well, cosine of 225, that's going to be our root 2 over 2, and that's in the third quadrant, so it's going to be a negative root 2 over 2 for our final answer there, because cosine is negative in the third quadrant. There we go. That's awesome, man. That's super dope, super fun, and super awesome, man. All right. So they look intimidating at first, right? but it's really just working backwards, and then it's like a super easy, like original style, trig problem that you did when you were learning the unit circle or using your special right triangles around the unit circle. And yeah, that's fun. A little throwback there. All right, hope you guys enjoyed it. Keep on watching them vids. See you later.